Hey guys, it's Miss Gephardt, and we're gonna tackle some notes on Earth's water resources. So we're gonna be really focused right now on all the freshwater resources. So make sure you pay attention and listen because some of the facts that I'm gonna talk about are things that are not on the screen, but you're gonna probably want to write down. All right, so the distribution of water on Earth. It's very important to obviously know how much water covers our planet. So 71% of the surface of the Earth is covered with water, which means the other 29% is going to be land. Okay, of that 71%, 97% of the water is salt water. So you think of all the oceans and all that kind of stuff. 97% is salt, and that remains that gives 3% remaining that's fresh water. Okay, so of that 3%, 2.2% of it is frozen, 0.6 of it is flowing. Okay, and any remaining percentage is going to be can be locked or trapped down in an area like underground or somewhere like, or even caught up in an atmospheric area. So when we think about how much water is fresh on the entire planet and we can easily get, it's easily accessible, 0.6 is a very small percentage if we think about that, okay? So where would we find water trapped in ice? All right, so we have to think we have different areas that we would look at, okay? So the first one is a glacier, okay? Glaciers are a large mass of ice that moves slowly over land, okay? And when we think of a glacier, I'm going to get my little pen here. Let's get purple. Okay, this is the glacier. We have to think of all this icy area, okay? This is the glacier, and glaciers are big, I mean, huge. When we think of huge, I'm thinking continental like size. Okay, because it's a big slab of ice and it just moves over the land. Okay, so this big, huge piece of ice travels over the land. Okay, so that's one area where we would find trapped ice. Okay, a second area is an iceberg. Okay, and it's important to note when we look at this that the iceberg, we see this small portion on top and this large portion at the bottom, okay? But this is, again, where we find ice that's trapped, okay? It's not something flowing. It's not something very usable for us in drinking water, but it is fresh water that's trapped. A third thing is permanent snow, and this just literally means exactly what it says. It's snow that's permanent, okay? So we would, if we were, climbing up this mountain, we would expect that all of this snow here would be there every single day. It's permanent, okay? This is all areas of fresh water that's being trapped, okay? Not something that's very usable for us, all right? So what's one thing that can be as hard as a rock, fill a glass, or float inside a cloud? And if you guessed water, you are correct. Okay, and I know we've talked about the different states and the fact that water is so unique that it can be found in these three states all at the same time. That's an amazing quality that that molecule has compared to others. All right, so we can see the liquid water, we can see it as a solid in an ice cube, and then the gas form as a vapor. Oh, and if you boil water, all that steam that's coming off, that's all water vapor. All right, so now let's look specifically at some freshwater sources on Earth. All right, so the first thing we're going to talk about is the difference between a watershed and a river basin. Okay, and essentially both terms and they describe the same thing. It describes land that drains into a river. So we think of the rain comes tumbling down and it hits the ground. Okay, and it's going to start. The water is going to be moving towards something. It's either moving towards a river, it's moving towards a stream, it's moving towards a lake, it's moving river, stream, lake, it's moving somewhere. So that's a watershed or a river basin. The difference between the two, a watershed is going to be referring to a smaller area. So this is small, where a river basin is going to be large. Sorry for my writing. Okay, there are 17 river basins in North Carolina. Okay, so something to kind of know, and that's something we'll expand upon in class. All right, so this is a river basin. Okay, so we can see all these little areas. Okay, all in here. They're all heading towards a main water area. So the water is draining towards a central area that's going to flow towards an even greater area. You can always, if you think about the Finding Nemo thing, all drains lead to the ocean, kind of think of it in the same vein that like little creeks and little streams and all that eventually all the water off the road, everything, they're heading towards something, and a river basin would be something that it's heading toward. Only difference with that and a watershed, they're the same thing, it's just the size. So this is a little bit smaller, on a smaller scale, as compared to a river basin. How are river basins and watersheds connected? Think of it in terms of a river basin is made up of a whole bunch of interconnected watersheds. So watersheds, think of those more like your little creeks and streams, and they all connect together towards this larger river basin. Okay, so it's kind of a way to think about how they're connected, even though they're all referring to the land that's housing the water as it falls or whatever, and it's draining off the land into some body. The watersheds are on a smaller scale. The river basins are much larger because they're made up of a bunch of watersheds. Okay. The water is flowing towards the lowest point. So we have to think the lowest point in a river or a river basin or even a watershed. Like a watershed, the water is flowing towards the lowest point, being in a river or a stream, a lake or an ocean. That's where these bodies of water are headed towards, just like I said. The Cape Fear River is an example of a river basin. Okay, so we can imagine all these sort of, it looks like a little highway of water in terms of the Cape Fear. And we can see right here, this is where the Cape Fear is going to be eventually leading into the ocean. But if we look back up in here, okay, we can imagine that there's a lot of areas of water that are draining towards a main large place. These smaller areas of the watersheds draining towards the larger river basin. Okay, all right, the difference between a lake and a pond. All right, so the difference is pretty much size, really, if we think about it. Okay, so Lake Wiley, this is a pond. It's called Houston Pond at Cornell University. I mean, you don't have to know the name of the pond. I just have to find a pond. But the difference, if you can see, is this has all these little pond grasses and such, all these little areas around here. There's grasses, and it's much shallower. There's a good chance that if in a pond you can see to the bottom. A lake, you're not going to be that way. Lakes can be very, very deep. So if I'm standing right here, or I'm not standing, I'm floating here in the lake, I'm not going to really be able to see the bottom. Where if I'm floating in the middle of this lake, or pond down here, I'm probably going to be able to see the bottom. Okay, that's pretty much and the other thing to think about with a lake is that the very bottom of lakes, there's areas where there's not going to be sunlight that penetrates, so we're not going to probably see the plant matter that we would see in a pond. All right, what are other examples of fresh surface water? And some ones to consider and ones to think about. First, we have streams. Think of a stream as a very small river or a large creek. Okay, so it's not wide in terms of this. It's very short. You can see it's very, very shallow. Kind of has a babbling brook kind of look to it. The next thing, or the other thing to look at, is a river. Okay, so this is much larger, we can see, in size across this way than it was to the stream. A little bit deeper, probably areas that are deeper in some places than others. Other examples of fresh surface water. So there's a couple other examples that we can look at and think of. Swamps. Okay, swamps, these are a type of wetland, okay, and these are this particular swamp is dominated by trees. You can see that, but a swamp is a type of wetland, and a wetland is where the water table is at, near, or above the land during the year to support a plant growth. So what we want to think with a swamp is that the water level is either right at the land or just above it. So it's not like this is going to be like crazy deep in here, okay? And there's probably going to be times where we see that it's shallower. Another one is a bog. Okay, so these are also not crazy deep in here. And this one particular is a bog that's dominated by peat moss. You may have also heard of bogs. If you ever watched the Ocean Spray cranberry drink commercial, they're standing in a bog because cranberries grow in bogs. So they're not, I mean, obviously they're standing there. They're not very deep. But these are areas that are going to have water enough to continually support plant life. Okay, it's not crazy deep, but it's it's not like a pond though. It's shallower than that, but it's gonna have enough to keep plants around. Marshes, if you've ever gone to Charleston, South Carolina, or even like Savannah, you'll pass through areas where we see these marsh grasses, very tall grasses, very shallow water areas. So enough water again to keep that support, especially in a marsh area. We're going to expect to see the water levels rise and fall depending on the tides. Okay. Turnover is when water, as it gets warmer, or as it gets colder, I'm sorry, it sinks and then it sort of cycles. So it's kind of like when we talked about convection currents in the earth. When we see it, we're going to see colder months, the water's all going to be cold. As the spring comes about, this water starts to do this mixing routine where the warmer water is going to rise, and and then the colder water will sink, and it just kind of does this whole turning. In the summertime, there's not going to be any turning. So we don't see any turnover in the winter and the summer. We're going to see the turnover in the fall and the spring, because the spring, it's getting out of the cold and starting to warm up, and in the fall, it's getting out of the warm and starting to cool down. So it's just sort of this mixing with this water, warmer water rising, colder water sinking. Final term that we're going to talk about for notes is something called eutrophication. Okay, and all you need to know with eutrophication is that there's an increase in nutrients that leads to eventually the formation of a field or a field. It's actually going to lead to a field. What that means is the water is getting pumped full of nutrients. Think about plants like fertilizers and stuff like that. So fertilizers are nutrients. If I put a lot of nutrients into a water, like a shallow place, especially like a pond, it's going to cause the plants to grow and grow and grow. Over time, that growth is going to lead to where you kind of see this like scumminess on the surface, and over time the water is leaving, the water is evaporating, the water is going away, till you get to a point where it actually will completely go away, the water will, and it's going to be a grassy area. Okay, and in terms of our stuff, we sort of speed up eutrophication because we add a lot of stuff into water that is a nutrient that causes plants to grow. All right, so hopefully you've gotten all your notes down. You're going to be doing further information on some of this. If you have any questions, please ask your teacher, and make sure you take your notes quiz right afterwards so that you have that and you write that quiz grade down. All right, until I talk to you another point in time.